today's lesson is actually going to be kind of nice because it goes off of what we did yesterday and the day before. So we spent 2 days on our prime factors and making factor trees. And today, all I'm going to do is show you an easier way to write your answer. So we're still going to be working on prime factors, and we're still going to be using factor trees and finding the prime factorization of a number. But the extra thing that we're going to do is I'm going to show you an easier way to write your answer. So it's actually a pretty cool lesson because it's going to make your life a little bit easier. So let's look at the essential question. So we're talking about strategies that can be used to multiply whole numbers. So yesterday we talked about how we're breaking down numbers, and we found 2 factors that you can multiply together to get a number. And the day before we worked on the same thing. So now we're still working on the same thing. Remember, these are all tools that you can use to help yourself when we're multiplying. Here's your problem of the day. What number is 3,045,101 more than, I'm going to underline that because that's some important words, 1,100,001. And it actually asks you to write your number in standard form and in word form when you get an answer. So since the question says more than, what operation are we using? Addition. So we're going to be adding those 2 numbers together. So you have to take the standard number and the word form number, and you have to add those together. Okay, so turn that word form into standard form, add them up. When you get an answer, you're going to give me standard form and word form. Take a couple minutes. So we have 3,045,101 plus, and then I'm going to read this other number in word form. So it's 1,100,001. So we'll look just like that. So then when we go to add them together, now we're going to see how much we have as our answer. So I got 4,145,102. So if you did the word form, if you got to that part, look at the word form of your answer and see if it sounds like this. 4,145,102. So that would be the right answer. So some people may not have gotten the chance to do the word form. Most people did. Okay, now you can erase your whiteboard. That was a good way to get our brains thinking for math today.
My brain's broken.
Hopefully not. Okay, here's chapter 2. You should have chapter 2, lesson 3 written in your notes. Now there's a question here at the top of this slide. Make sure you're listening, not talking. So the question at the top of this slide says, is there a more efficient way to represent repeated multiplication of the same whole number? So this is what the question is asking. When you have a number, remember yesterday when we did an answer that looked like this? I think there was 5 of them. So this is what it's asking. Is there a more efficient way to write that answer instead of writing that many 2s?
Yes.
So there is. And here, let me show you what it is. And this is what we're doing today for our assignment.
It's called an exponent.
It is called an exponent. Look at that. So we have 1, 2, 3, 4, 5 2s. So our base is 2. And our exponent is 5. So here's what I want you to have in your notes. That wasn't it, so don't feel confused. Some people seem like they get it and they might remember this from last time. Here's the base. This is what needs to be in your note, everything I've written on this slide so far. The base is the number that is repeated. So I want you to write that. So the base is the number that's repeated, and then the exponent, which is the other number, is the number of times that it's repeated. So in this case, we had a 5 up here, so that number is the exponent. So this is times that it's repeated. Sorry, that smushed That smushed all the way over there to the edge of that slide. So I'm not going to go on. This is the base. This is the exponent. So I didn't write, it's not a 25, right? It shouldn't look like a 25 in your notes. It should look like a bigger 2 with a little teeny tiny 5 up on the corner.
I think I already get this.
So 2 is the base. The 5 is the number of times that it's repeated, which is the exponent. Yes.
Oh. We got it. Soon don't we have to be using dots as multiplication sign?
We'll do that, yeah. Sometimes we will. It depends. Usually when we start doing algebra, where we start using letters in our math, we don't use the X. We don't use the X for multiplying, we use a little dot. Because in X, sometimes we're going to be using letters, and that would be confusing. Yes?
Can I go to the bathroom?
Give me a ticket, and then you may go to the bathroom. Okay, so I'm going to erase this one. Everybody have this part written down? So we have, oh, okay.
Yes, I do.
Finish writing this, because I don't have a lot more to say about this slide. I need to write some more examples. If you have already done this, here's what you can do next. You can find the prime factorization of 30. That's going to be our next example. So in your notes, because in order to do these, you're going to have to start with what we've already done, which was prime factorization. So find the prime factorization of 30. So that is making a factor tree with 30 as your starting number. So try that while people are finishing copying this up. Get it from a friend. 30, if we're finding the prime factorization of 30, oh, this wasn't a good example because you don't have a repeated factor. So you have 6 and 5, or you could have started with 10 and 3, or 15 and 2. 5 is prime. 6 would be 2 and 3. So my answer is 2 times 3 times 5. Not a good example for this one. Sorry about that. So because there's no repeated factor, like there's not more than 1 2, there's not more than 1 3, and there's not more than 1 5, you would just write the answer like this. When you get something like, let's try 25, I know that has a repeated factor. What are the factors? What's 2 factors of 25, Angelina?
5 times 5.
5 times 5. And those are both prime, so we circle them. Then we're going to write, we could write it like this. This is what we've been doing, right? This is what we've done the last 2 days. You would write it like that. But then you could also write this using exponents, and it just makes it easier for you to write it. So it could also be written like this. 5 is the base, because that's the repeated factor. And how many times is it repeated? Show me on your hand how many times the 5 is repeated. How many 5s do you see? 2. So 2 is the exponent. So that would be your answer. So today's lesson is using what we've done the last 2 days, finding prime factorization, and then changing it into the prime factorization using exponents. So in the future, it's probably like on your math test, it would tell you to either do prime factorization or prime factorization using exponents. But really, this is the more efficient way to do it. So if they don't tell you a way, you can do it either way. But this way is really an easier way to write it. It's less writing that way.
So what?
Yes, Nolan.
I was gonna ask, wouldn't you read it like 2 different ways? If it was 2, wouldn't you say 5 squared?
You could say 5 squared because it's a 2.
Also, if it was like a 3, you would have said 5 to the power of 3, right?
Right. Really, the way we would read this was 5 to the power of 2. You could read it like that. Or 5 with an exponent of 2. You could say that. Could say 5 squared. We haven't really got to that yet, but yes. Well, we haven't gotten there yet. We aren't finished. We've only done one example. We've only done one example. Something else that you're going to see on your assignment is if they give you something like this. And what they want what they want you to do is figure out what this number equals. So the first example that we just did was kind of like what we've done already. So we had to do a factor tree, and then we had to take those factors, the prime factors, and we used exponents to show the answer. Now we're gonna like go in the reverse. So now they're gonna give you the prime factors with the exponent, and you have to figure out what it equals. So here's what I would write for this question, and this is what I want you to write in your notes. Because that way, once you get started on the assignment, you can use your notes and say, oh, when I saw a problem like this, what did I do? This is what I did. Anthony, put that page away and use your notes. Using notes. We're going to write it in the notes. So here's what 2 to the third power equals. It really means 2 times 2 times 2. So I'm going to ask you a question. And I don't want you to say anything. I want you to give me a thumbs up or a thumbs down, and you don't have to do it above your head. I want you to do it right here in front of you. Do you think that 2 to the third power equals 6? Yes or no? Don't say anything. Yes or no, or in the middle if you really don't know. So 2 to the third power equals 6, right? Yes, no, don't know. I'm going to hold this for you so you're not distracted. Take notes. Ooh, I see lots of no's. That's good, because the answer is no. I saw some don't knows. So 2 to the third power, anybody know what it equals if you just raise your hand? Hamza, what does it equal?
27.
Ooh, 27.
Where did you get 27?
That's a big number. Ashley? 8. Anybody agree and disagree? I'm not sure how you got 27. We'll figure that out though in a minute.
16.
It doesn't equal 6 because those are multiplication signs, right? In between each of the numbers, you're multiplying. So it doesn't equal 6, and that's what's the trick question I was asking you, because 2 times 2 equals 4, and then 4 times 2 equals 8. Okay, so that's what you have to remember. So a lot of times people will put 6 on there because they think 2 plus 2 plus 2 is 6. But it's not, you don't take these numbers and multiply them. Like you don't multiply 2 times 3 and get 6. You multiply 2 times 2 times 2. So as we kind of move forward here, you're going to see a bunch of the same repeated numbers. Like 2 to the third power is always going to equal 8. 2 to the third power will always equal 8. So when you see 2 to the third, you know it's going to equal 8. What would 2 to the fourth be? Like this. What would that be? Anybody know how much that would be? What do you think, Karnpreet?
2 to the fourth power would be 24.
He says 24. No. What do you think? Yes, no, don't know? Amy, do you have a different answer? 16. Yes, no, don't know? What do you think? Amy says 16. If 2 to the third power was 8.
It's 10.
16.
Oh, is it 10? Oh, he has another answer. 10?
No. 16.
16. I hear some 16s. So 2 to the third power equals 8. 2 to the fourth power means you're going to multiply it by 2 again. So 16 is the right one on this one. You went you went a little bit further. You did something else. So 2 to the fourth power would look like this. So in your assignment today, if you see this as the question, like 2 to the fourth power, on the line to show your work, you need to write it out like this. And then you can do what I did up here by multiplying. You could even do this if there's an even number of things. 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. So you could do it that way too. So you are taking the number, the base, and you are multiplying it by the number of times the exponent tells you to. So in this case, we multiplied it 4 times. It's not 2 times 4, it's 2 4 times, which is different. 2 times 2 is 4, 4 times 2 is 16, 4 times 2 is 8, 8 times 2 is 16. That's how you get to the final answer. We're going to do more examples. Let me give you 4, because the base is not always 2. So what if the base is 4 and the exponent is 2? Now what? Don't tell me the answer. Tell me what are the numbers that I'm multiplying here. What is my base and how many times is it repeated? So what is my base? Someone show me on your everybody show me on your hands what is the base? Base is 4, right? That's the number that's repeated. Now show me on your hands again, how many times will I repeat the 4? Okay, so 4 2 times. Oops. Reverse. I was talking while I was writing. So 4 times 4 is what that means. It's 4 repeated twice. And I'm not adding them, I'm multiplying them. So what do I get? 16, right? I heard some 16s whispering. Right. What would you like to say?
Even though the 2 and the 4 switch places, it's still going to be the same answer, even though they're switching areas.
So the last number we did was 4 to the second power. 2 to the fourth power. This is 4 to the second power, and we did get the same answer. The base and the exponent switched places. That's what he's showing us. Okay, let's try another one. This one works out a little bit differently, so I want to make sure that you have one of these in your notes. Try 24. I want you to do it by yourself in your notes, and then I'm going to show you what I have, and we're going to see if we have the same thing. Don't share answers with the neighbor yet. Try to show the prime factors using exponents. So you could start with a bunch of different things actually for this number. I'm going to start with 8 times 3. You could start with 6 times 4. You could start with 12 times 2. All of those are going to get you to the same answer at the end. I'm going to circle the 3 because it's prime. Then I'll go here with the 8 would be 4 times 2, and 2 is prime. And then I break down the 4 into 2 times 2, which are both prime also. So now my answer looks like this: 2 times 2 times 2 times 3. Now, this one's different than the other ones we've done so far because this one has 3 numbers that are the same and 1 number that's different. But it doesn't really change what we've been doing. How many 2's do we have? 3. So my base is 2 and my exponent is 3 because there's 3 of them. But then I can't forget about that little 3 there too, so I just have to do that. And the 3 doesn't have an exponent because it's not repeated. Okay? So if the number doesn't have the exponent, or if it's not repeated, it doesn't have an exponent. Okay? Angelina. It's not a remainder. Don't think of it like a remainder. But yes, when you write like R4 or whatever, when you're doing, yeah, it kind of looks like that, but it's not. It's not the same thing. Okay, you can go to the back if you need to go to the back. Okay, on your whiteboard, I want you to try this question. Sure. You are finding the prime factorization of 54. So try this one on your whiteboard. Prime factorization of 54 with and without exponents. So first without exponents, like what we've been doing, and then change it into using exponents. Okay? Let's look at factors of 54. So what times what is 54? 6 and 9. Now neither of these numbers are prime, right? So we need to break them both down like this. 9 would be 3 times 3. 6 would be 3 times 2. And now we have, without exponents, 2 times 3 times 3 times 3. With exponents, we have 2, not repeated, right? 2 is not repeated this time, times 3. That's repeated 1, 2, 3 times. So 2 times 3 to the third power should be your exponent. Do you see all we've done was we just condensed it and made it an easier way to write it. Hold on. Let's listen. If you have a question, then remember, like we talked about yesterday, don't wait till the end when you're starting to work to ask your question, because I don't want you to sit the rest of the lesson and not know what to do. So if you have a question, think of what you're going to ask, then raise your hand, make sure your hand is up, and then I'll call on you. Somebody else might have the same question as you. So I'm going to pause this. Okay, so now we're going to look away from our whiteboard. Good questions. We're going to look to our math page, which is on example number 1 in your Math in My World page. Page 93. This is not, oh wait. This is not your free working time. We're still doing some examples. If your paper is not stapled, that's not an emergency. Wait, no. We're not putting away whiteboards. What if I ask you to use it again? We're not throwing markers in the can. We're not stacking up our whiteboards. Just hold them in front of you. We have some more things to do, and then I want you to be able to have your full 20 minutes to work on your assignment today. So this one says the number of calories in 6 pancakes can be written as 10 to the third power as a product of the same factor. Then find the value. So we have 10 to the third power written there. 10 times 10 times 10. See what they've done here for you? And then they've written it here again. So 10 to the third power would be 10 times 10 times 10. That's 30, right?
So 10 and...
Is that 30?
Yes.
Oh, I'm trying to trick you, and I think I didn't. I tricked a couple of you, but some of you were shaking your head. No, it's not 30 because those are multiplication signs, right? Those are multiplication signs. So it looks like this. Watch. 10 times 10 is 100. What is 100 times 10? Nolan.
100 times 10 will equal 1,000 because if you count by your hundreds, you can't go to 100.
Right. So basically, because these are powers of 10, because we're working with tens, all you do is add another 0 onto the end.
Don't say 2,600.
So, listen carefully.
That's a lot of calories.
Listen carefully. Number one thing that people do is they start this assignment and they're adding these numbers and not multiplying them. And then what happens is you get them all wrong tomorrow and you have to go back and fix them all because then we start working on something else and you don't want to have learned it the wrong way. So pay attention. It's not 30 and it's not 300 or 3,000. I heard just because there's 3 numbers that doesn't make it start with a 3. 10 times 10 is 100. 100 times 10 is 1,000 because you would add a 0 to the end of it. So 6 pancakes have 1,000 calories. Write that in on page 93.
Then just combine them all into one.
Because we're multiplying, not adding. Yeah.
That's only if there's a 1 in the front. Don't do it with other numbers.
So here's the next part that's at the bottom of page 93 for you guys. Wait for all your voices to turn off. Every single one of them. Want to make sure everyone hears. So this part says that this is like your vocabulary part. We've already talked about these. Numbers expressed using exponents are called powers. So that's why we would say like 2 to the power of 5. So we call them a power. Numbers that are raised to the second or third power have special names, as Nolan shared with us earlier. If the number has a 2 next to it, you would call it squared. Or you could say 3 to the second power or 3 to the power of 2, but you could also say 3 squared. And then if the number has a 3 next to it, you could say, like in the example, 10 to the power of 3, or you could say 10 cubed. Okay?
Would you have to write cubed in words?
No. We're not going to need to be writing any in words. Right. Okay, so look on this one. What is the base? I have 3 times 3 times 3 times 3. What is the base, Angelina? 3. 3 is the base. And since 3 is used as a factor, like she just said, 4 times, then that means that the exponent would be 4. So if the question asks you to write as a power, it means you're writing it using an exponent. So the base is 3, and the exponent is 4. So the big base is 3, and the tiny exponent is 4. Whatever helps you to remember. And last example, the prime factorization of 72 using exponents. And so this is another one where they've asked you to fill in this factor tree. So what times 9 equals 72? What is it?
6. Or no, 7.
No, 8.
Oh, didn't you say 8 at the beginning?
I said 6.
Okay, 8. It's 8. 8 times 9. So then we break down the 9 into 2 3s. And in this case, they've carried them down. You could also circle them and not use these boxes like we did yesterday. To break down the 8, you could do 2 times 4. And then we're going to leave the 2 because it's prime. And then the factors of 4 would just be 2 and 2 like they always are. Now we're going to order the factors. See how part number 2 is asking you to order them least to greatest? It's because that way you don't miss anything. You don't want to miss any of those exponents. So we have 3 2's and we have 2 3's. So in step number 3, they've given you the base, but then you need to fill in the exponent. So what would be the exponent next to the 2? What would be the exponent for the base of 2, Alexis?
2.
How many 2's are there?
3.
3. You'd have a 3 next to that. And then how many 3's do we see? Amelia? 2. So then we'd have an exponent of 2. So 72 equals 2 to the 3rd power times 3 to the 2nd power. That one's kind of confusing because we just switched the numbers there. So on the assignment today, you're going to see some different examples of what we just saw. So we had a couple different. Sometimes it's going to show you a factor tree like this one, and it's going to ask you to list the prime factors using exponents. Sometimes it's going to give you the exponents and want you to figure out what it equals or what the value is. And then sometimes it'll give you already the prime factorization and just ask you to make it into exponents. So the last 3 examples that we just did together on your paper, you're going to see examples like each of those during the lesson. So look at the examples if you get stuck. So if you look at the problem and it just has this, and then you read the directions but you're not really sure what to do, go back and look at these examples that we did and see what we did when we saw this. We would probably do 2 to the 3rd power, or might want you to tell them that equals 8. Okay, you kind of have to read the directions to see what they want you to do, because you could be doing any of those things with this assignment. Okay, guided practice first, then double check it with people around you. Today we're doing the whole thing, so we're not doing just odds and evens like yesterday. Today we're doing the whole thing. So look very carefully. I'm going to put up your timer. Last 5 minutes are all by yourself.